So today we will be continuing our Thevenin's theorem class, but this time we have already learned how to solve for Thevenin equivalent circuit, but today we will solve Thevenin's theorem with dependent source, with dependent source. So how to solve? We already saw the steps to convert any circuit into Thevenin circuit, but this time when a dependent source will present, slightly our step 1 to solve Thevenin circuit was to remove the load. Okay, remove the load and calculate VTH across the terminals. This was the first step to calculate VTH, so this will remain intact, same thing. Our second step was to calculate RTH by sorting all the voltage sources and by sorting all the voltage sources, V sources, and open circuiting current sources. Using series parallel techniques, we have already find out RTH in our previous lectures, circuiting current sources. But this thing only will change because when a dependent source is present, suppose we have an example. Okay, let us suppose we have an example. Okay, we have an example over here. We have a dependent source present here. Okay, suppose it is 6 ohms. This is this be Vx. Okay, and it depends on Vx. This is 2 Vx, the voltage source. This is 3 ampere load current source. This is 18 volts of battery, plus and minus. Okay, this is 1 ohm. So when there is a dependent source present over here, I cannot open circuit this current source and short circuit this voltage source. I can short circuit this voltage source, but I can't open short circuit this voltage source because there might be a hidden resistance present over there, because it's a dependent source voltage source. It is depending on voltage only, but still there may be a hidden and variable resistance over there. So I cannot just short this circuit, and if it was a normal circuit, then I would have just short circuited it, open circuited it. Okay, and just calculate the resultant which was like only this 1 ohm. It would have been the resultant net resistance across these two terminals after removing the load. Okay, but we will not do this. So what we will do here, we will use the step 2 will be changed to what we will do now. We will short circuit the terminals where the load was present, and we will find out. We already found this is A terminal and this is V terminal. We will already find out VTH in the first step, which will be equal to VAB, and now we will find out the current with all the sources present. We will now find out the current, which will be termed as IAB. Okay, so RTH will be RTH. Okay, will be VAB, or the Thevenin voltage, both are same. Okay, upon the IAB. Okay, these both are same, it is OR. Okay, VAB, either VAB which will be same as VTH upon the current, which we will be finding out using mesh analysis. Okay, so the RTH will be equal to V Thevenin upon IAB. So this is the new method. If a dependent sources will be there, then we will use this method to find out the current. Okay, so we will be solving this example only so that we can know better. And one more thing here, two cases may arise. In the RTH may also come negative over here. Okay, RTH may also come negative, but resistance cannot be negative, you all know. But still we will use in the Thevenin circuit, suppose a negative value of resistance came, still we will use minus 45 only to solve the circuit. Suppose for example 45 is coming. Suppose for example 45 is coming on negative, any value of negative is coming RTH, we will, with the load, we will use minus sign only. Okay, with VTH circuit, we will form the circuit, but the negative with the negative value of resistance, so that the magnitude becomes correct. Okay, if the negative comes, we will use the negative sign here also, because we will, if we are finding VTH is VA minus VB, that is from starting from A and come to B and write the voltage drops, then the current should be also in the direction of IAB. Just one negative sign implies that the resultant, the net resistance was in the parallel order, so that net resistance is getting decreased, and that's why summation of the resistance will decrease and we will get the correct answer. So after the solving the problem only we will able to know. So let's start now. Look at the examples, the same example, and let's try solving the example so that we can easily understand the concept, because when we solve the example we will easily know how to solve, and it will be much more clearer than the theory part. Okay, so I take in the same example, 6 ohm R equal, this is the RL, this is 2 Vx, this is 3 ampere given, this is plus Vx, this is 1 ohm, and this is 18 volts. Okay, let's solve this question. Find Thevenin's circuit. Okay, Thevenin's circuit around 6 ohm resistance. So this is our load. So step 1 is to calculate VTH after removing load. So let's remove the load. I remove the load. So load was present in between these two terminals, A and B. It's 3 amperes, it's 1 ohm, minus plus Vx, this is 18 volts, 2 Vx. Okay, so now this is an open circuit, so no current will flow in this mesh. Let us assume the current to be I over in this mesh. Okay, so let's write. So 3 ampere current is flowing upwards and I is flowing downwards in this branch. So I is nothing but minus of 3 amps. Okay, the I is the same current which is 3, because in one branch only one current can be present, because here is an open circuit, so no current is flowing over here. So I is same as 3 amperes, but in the opposite direction, so we put a negative sign over here. Okay, so I1 equal to minus of 3 amperes, first equation 1. So now write a KVL equation. I want VA minus VV. Let's start from this point and come again back to this point. Okay, so we will know what is VA minus VV. So I start from this, I am writing KVL equation. So plus of 2 Vx, again plus of Vx, plus of 18 equal to V Thevenin. VA minus VV is the only VTH. So VTH is nothing but 2 Vx, 3 Vx plus 18 equal to V Thevenin. Now how to find the value of Vx? We already know the current to be minus 3 and the resistance is there, so Vx. So current, so let's write from this direction. So minus of Vx is equal to, current is flowing this direction, so I into 1. Okay, I into 1. So minus of Vx will be, I is nothing but minus 3. So Vx will be equal to 3 volts. Okay, so Vx will be equal to 3 volts. And why I write in minus V? We have to go from any one direction. the drop from this point to this point is Vx, and from this point to this point is minus of Vx. Suppose first case, this point to this point I am coming, so the current is in opposite direction, so I have to write minus of I into R, because from when I coming from this point to this point, I got a positive drop, positive to negative drop, but the current direction what I assumed is of my opposite, so that's why I put a negative sign over here. But when I'm coming from this side to this side, I am encountering minus sign first, so minus of Vx, but the current direction is correct, because what I assumed, I am going in that same current direction, so that will be equal to I into R. So that's why it's very important, the sign convention is very very important. So I got Vx, so now the V Thevenin will be equal to nothing 3 into 3 plus 18, so it will be equal to 27 volts. So I already got V Thevenin. So once I got V Thevenin, now the part is the tricky part to calculate RTH. Just looking RTH, so how to calculate RTH? Okay, so we will be calculating RTH. How? Which method? I told you we will not use series parallel technique because a dependent source is there. So what we will do is short circuit the open terminals. We will short circuit the open terminals. We will just short circuit the open terminals, and we will find IAB. This is IAB, and RTH will be nothing but VTH, which we already found over here, upon IAB. So this is the IAB. We have to find this IAB. This is plus minus 2Vx. This is 3 ampere, and this is 1 ohm resistance is 18. So we will have now two mesh current, I1 and I2, since it's a closed circuit. So first equation we got is I2 minus I1 equal to 3 amps. It's very obviously I2 minus I1 will be equal to 3 amps. Why? If we look at why, because I2 is going upwards and I1 is going downwards, and the net current is upwards 3 ampere. So a difference of I2 minus I1 will be positive of 3 amps. So now this is my equation 1, and now solving for equation 2. So to get equation 2, what I can do is write a KVL. This is nothing but Vx only. Okay, this is dependent source depending on this voltage source. So let's write a KVL equation over here, and the KVL equation will be 2Vx. I'm starting from this point and coming back to this point. 2Vx plus Vx plus 18. I came back to this point. Okay, it came back to this point, will be equal to 0. Okay, so now 3Vx equal to minus of 18 implies that Vx equal to minus of 6 volts. So now I got Vx also. So when I got a Vx, and I also got I2 minus I1 equal to 3 amps. So what we want to know? We want to know this IAB. IAB is nothing but I2. IAB is nothing but I2, and we can also write Vx is nothing but minus of Vx, because I1 is flowing in this direction. So minus I encounter first, minus of Vx equal to, this is the positive direction of current, I1 into 1 ohm resistance. So I1 is nothing but minus of Vx, which will be equal to minus of minus 6, will be equal to 6 amps. I got I1. So from that I2 minus 6, I am putting the value of I1 in there, equal to 3 amps, and I2 I got to be 9 amps. And I already told you, here we can see I2 is flowing, and in this line IAB is flowing, same branch, same current, so I2 and same direction also, so no negative sign. I2 is equal to IAB, so RTH will be equal to VTH, which was equal to 27 volts. You can already check over here, it was equal to 27 volts, divided by IAB, which is equal to I2 here, so 9, so RTH will be equal to 3 ohms. So RTH is 3 ohms. We've known the value of RTH. It is equal to 3 ohms. Easily we can calculate. So what will be the Thevenin's equivalent circuit over here? You can easily tell. So the equivalent circuit will be, Thevenin's equivalent circuit will be VTH. So VTH was 20 plus of 27. So A terminal will be with the positive one. So this was 27 volts VTH, and now the RTH is positive of 3 ohms, because independent sources sometimes for getting the magnitude right, negative resistance also may come, so be careful about that. So we will see an example of that too, don't worry. So 27 volts and RTH is nothing but 3 ohms, okay, and this is our load resistance of 6 ohm. So what is the I load? If we want to calculate I load, is nothing but 27 upon 9 equal to 3 ohms. Okay, so this was how we solve Thevenin circuit, Thevenin equivalent circuit when dependent source is present. Dependent source is present. Okay, so now look at another example. Let's look at another example. So now let's look at this example. We have a circuit and our load is this is our RL. I want to find a circuit around this resistance, Thevenin equivalent circuit. We have a dependent source over here. So let's start. First step is to calculate VTH, remove the resistance and make a point A and B. Minus plus 10 Vx. This is nothing but Vx plus minus Vx 5 ohm, and current source is there of 10 amps. Okay, we have a potential drop of 100 volts over here. So no current is flowing here because it is an open circuit. I equal to 0 in this mesh. Okay, so now write VA minus VB, which will be equal to VThevenin. Let's start from A. Let's go like this. It's a drop of 100 volts. Now 100 volts minus, here if we go, it's minus Vx, and again if I go that side, it will be plus 10 Vx. This will be equal to VThevenin. To find Vx, we already know. So here the current is flowing like this. Okay, it's already maintaining the current. The current source is maintaining the current. So this is the direction of the current flow. So if I come from this point to this point, I have a drop of plus of Vx. So plus of Vx will be equal to, so this direction my current is positive current. Already mentioned this direction current is positive, because if I assume also this had to be positive, but in this case I can't assume an arbitrary, because already the direction is given, which is maintained by the current source. Positive of 10 is flowing clockwise. So it will be equal to plus of Vx will be equal to this R resistance is there. Current is positive direction current, so plus of I into resistance, which will be equal to 10 into 5. So Vx is nothing but 50 volts. So V Thevenin is nothing but 100 minus 50 plus 500. So it's nothing but 550 volts. We already came to know what is the Thevenin voltage. So already I told you to find RTH, what we have to do? We have to short circuit this, okay? We have to short circuit this and find IAB. So what IAB will be there? Now the current will be flowing. So now the current will be flowing, I will be flowing, because I short circuited and it makes a complete circuit now. So the I1 will be I assume in this direction will be flowing like this. So RTH will be equal to nothing but VTH by IAB, and in this case it will be nothing but VTH by I1. So let's write the equation. Now for this circuit, let's write the equation. So what will be the equation? After short circuiting this, we have I1 over here and I2 over here. I assumed I2 to be like this. This is positive direction for this I2. So here we can simply write two equations. First of all, one equation will be, let's start from here and write a KVL equation like this, okay? So it will be equation 1. Let's write over here. So we have this, okay? Let's write the equations here. For that circuit again, I short circuited A and B, okay? So it is like minus plus Vx, okay? So no problem for that. Okay, I drawn the circuit again. Just the thing is that I want to find RTH which will be equal to, if I found this IAB, which will be nothing but VTH already found, which is equal to 550 volts upon IAB, which we are going to find, okay? So this is 10 amperes of current and this is our 5 ohm resistance. Let us assume I2 to be flowing like this and I1 to be flowing like this. We can't have say in this, but we can assume the I2 to be flowing like this, but then I2 will be equal to minus of 10. So if I assume like this, it's better because it's already a current source and it is maintaining a current of 10 ampere in this direction. So now to find RTH, we have to know IAB, and here I1 is flowing. I assumed in the same branch IAB is also flowing, so I1 is nothing but IAB. So I have to find I1. So IAB is only flowing in this mesh, okay? So let us write down the KVL equation. This is nothing but 10 Vx as per question, and this is nothing but plus of Vx. So let's start from this point and again come back to this point and write a KVL equation. So minus of 10 Vx plus Vx. We are not using IR to write here because we don't want to increase our unknowns, okay? Minus of 100 equal to 0. So minus of 9 Vx equal to 100 implies that Vx equal to minus of 100 by 9 volts. We came to know Vx. So now when we know the Vx, to find I1, we know that here is the Vx. So to find I1, what we can do is that let's write one more equation. We know that here the voltage drop is Vx. So if you use V equal to IR plus of Vx, here two currents are flowing. I1 from plus to minus only. The positive direction of I1 is flowing from plus to minus only. From this point to this point, I write in plus to minus, and from this point to this point, plus of I2 is flowing. So it will be equal to I1 plus I2 into 5. And I2 is same as here the branch current is 10, which will be equal to I2. So plus of Vx will be equal to nothing but I1 plus 10 into 5. So Vx by 5, Vx is nothing but minus 100 by 9, minus 100 by 9. So it will become 45 when the 5 will go down there. So I1 plus 10. So I1 will be nothing but minus of 100 by 45 minus 10. So it will be equal to nothing but minus of 550 by 45. So RTH will be nothing but RTH will be 550 upon minus 550 by 45 equal to minus of 45 ohms. So this was I was talking about. Sometimes we have to always use the correct sign conventions, because I assumed VTH to be VA minus VV. That's why RTH is VTH upon I A to B. Okay, A to B. That's why the current direction is A to B. So due to some my mistakes of judgment of directions, the resistance have become negative. But now I have to use as it is in the Thevenin's equivalent circuit or the case of dependent sources, because then only the correct magnitude will come. That means the dependent source resistance must have been in some parallel manner in order to decrease the resistance of the equivalent circuit. So that's why the net circuit will be RTH equal to minus of 45 ohms, VTH equal to 550 volts, positive connected to the terminal A, and the load which was equal to in the original question 10 ohms. So the load current will be equal to 550 upon minus 45 plus 10. So it will be 550 upon minus 35. So the IL is negative. That corrected my direction. The negative sign here only that corrected the direction of my assumption of the IL. But since it was negative, it also corrected the magnitude of the IL, because if I would have taken a mod of this resistance, because negative resistance cannot be negative, then it would have been 35. So when a dependent source is there, so the negative signs of resistance indicates two things. Maybe the direction of current was assumed wrong, or otherwise because it's a dependent source we can clarify it, or other it was in a decreasing manner of the resistance. So the net resistance was decreasing, so it was a parallel order of a combination of the resistance. So this is be very careful. So whenever a dependent source is present, we will just use first step to calculate VTH after removing the load and open circuiting it. So VA minus VB will be the VTH. Normal Kirchhoff's laws will be followed to find the VTH, but after that we will short circuit the end result to find IAB, and dividing that from VTH we will get the RTH, whether it's negative or positive, using the circuit. So this is how we solve Thevenin's equivalent circuit when a dependent source is present. Thanks for watching. Let's meet in the next lecture.